Okay, so we're looking at some theorems in trigonometry that are quite useful, and they're called the addition theorems. So you're either adding a positive number or you're adding a negative number. Now the proofs behind these are available quite easily through textbooks or online, but we'll just go straight to the formulas. So what we have is you can either have a plus or a minus, and with the sine one, the plus and the minus are the same in the same order, and the ratio is sine A cos B. So whatever this number is, you put first, and whatever the second number is, you put second, and then the second part of it, you switch the cos and the sine around. For the cos, with the plus and the minus, they switch over to minus and plus, so they go the opposite way. So you've got the two coses first, and then the two sines are second. And then with the tan, with the plus and the minus, with the plus and the minus, they stay the same on the top, and then on the bottom they switch over. Okay, so again, the proofs for these are quite easily available through textbooks, but we'll just go straight to the using of them. So copy that down and come across when you're ready. Okay, so we're looking at just a few examples. So the first one is just something, we don't know what the numbers are, and we're going to do cos of it. Okay, and so we're going to have, so we've got the cos relationship, so it's going to be cos 2x cos 3y, whatever that is. And because it's a plus, we switch the sign over, and so we have sine 2x sine 3y. So we don't know what these numbers are, but that's what we just do there. Okay, and this next one, we've got a tan relationship. So we have tan A plus tan of pi on 4, which we'll get a value for in a sec. And then we have 1 minus, because we switch the signs over. Now from our exact values, tan of pi on 4 equals 1. And so the answer is going to be tan A plus 1 over 1. Now this is 1 again, so it's just going to be 1 minus tan A. And that's all we can do. We can't cancel anything out. Okay, so copy those and come across. Okay, so now we've got some simplifying, and what we're doing is we're trying to use this next one, we're going to use the formula backwards. So you can see you've got sine, cos, and then we switch it to cos sine. So that means we've just got the sine relationship with a plus sign backwards. So the answer to this one, I'll just change colours. So the answer to this one will be sine of 3 theta plus 2 theta, and so the answer is sine of 5 theta. So just remember, like if we had that, then we would put the first number 3 theta first, and cos 2 theta second, and then switch it over. So we're just reversing the formulas. Okay, this next one, again, we're just having a look at an interesting relationship when you have 90 minus theta. So we've got a sine relationship, so we've got sine of pi on 2 cos of minus theta, and we've got a minus, so we keep the signs the same, and then we're going to switch it to cos of pi on 2 times sine of minus theta. Now, from your exact values, sine of pi on 2 equals 1, and cos of pi on 2 equals 0. So we've got sine of that equals cos of minus theta minus 0, and when you have cos of minus theta, you have the same as cos theta. Just to show you what's happening, so if you've got the angle theta, cos is this distance here, and if I have minus theta, cos is still the same distance, so cos of minus theta is the same as cos of theta. Okay, so this is what's called the complementary ratio. So what you've got is, if you've got sine of 30, okay, that's going to be the same as cos of 60, because you could have had 90 minus 60 to be your 30, and so the opposite number is 60, so you can put the same number there. So that's called the complementary ratio. Come across when you're ready, got one more to go. Okay, so we're going to use the expansion of sine A plus B to prove that that number exists. Now, previously, you've got these exact values that you've known, pi on 6, pi on 3, and pi on 4. They're the good numbers. Now, what I've done here is I've got 5 pi and 12, so I've just abbreviated them, I've turned them all into over 12s, so 2 pi, 4 pi, and 3 pi. So you've got to think about what numbers add together to get 5 pi on 12. And in this particular case, that and that add together to give 5 pi on 12. So that means that 5 pi on 12 must be the same as sine of pi on 6 plus pi on 4. And then we do our expanding out. So we've got sine of pi on 6 cos of pi on 4 plus cos of pi on 6 sine of pi on 4, and then sine of pi on 6 is a half, cos of pi on 4 is 1 on root 2, cos of pi on 6 is root 3 on 2, sine is 1 over root 2. So we end up with 1 plus root 3 over 2 root 2. And we know that the answer has to look like that. So all they've done is they've rationalised the denominator by multiplying top and bottom by root 2. So 1 times root 2 is root 2. Root 3 by root 3 is root 6. Root 2 by root 2 is 2. 2 2's are 4. And that answer is what you want. So we've got the right hand side, so it's a QED at the end. Okay, that's it. Thanks for coming.